Most people think offshore platforms simply float on the ocean. The truth is, what keeps them standing is hidden far beneath the water. Today, we'll go beneath the surface to reveal why these giants survive storms that can destroy buildings on land. Let's get started.
Imagine standing on the deck of an offshore oil platform, more than 200 kilometers from land, surrounded by nothing but open ocean. Beneath your feet is a structure weighing tens of thousands of tons. Above you, towering cranes, massive drilling equipment, steel pipelines, living quarters, helicopters landing only a few meters away. Now imagine something even more unbelievable. The entire platform is standing in water, hundreds of meters deep, while enormous waves crash against it day after day. Powerful ocean currents push against its legs. Violent storms strike without warning. And in some parts of the world, hurricanes generate winds powerful enough to destroy buildings on land. Yet, many offshore platforms have remained standing in exactly the same location for 30, 40, even 50 years. How? Why don't they sink? Why aren't they swept away by the ocean? What keeps a structure heavier than thousands of cars, standing safely in one of the harshest environments on Earth? The answer has nothing to do with luck. In fact, everything you think you know about offshore platforms is probably wrong. Because the real secret isn't what you can see above the water. It's what's hidden beneath it. Far below the waves lies one of the greatest engineering achievements ever created. A structure so incredibly strong that it can survive towering waves, powerful storms, relentless ocean currents, and decades of punishment from salt water without disappearing beneath the sea. But building something this extraordinary wasn't easy. Engineers had to solve problems that had never been solved before. How do you build a city-sized steel structure in the middle of the ocean? How do you stop thousands of tons of steel from sinking into the seabed? How do you make sure it can survive year after year while producing the energy that powers millions of homes around the world? Over the next few minutes, we'll take you beneath the surface to reveal the hidden engineering, the massive foundations, and the remarkable design that keeps offshore platforms standing against the unstoppable force of the ocean. Once you see what's really holding these giants in place, you'll never look at an offshore platform the same way again. At first glance, an offshore platform looks like an enormous steel building floating on the ocean, but that's one of the biggest misconceptions people have. Most offshore platforms aren't floating at all. They're standing on one of the strongest foundations ever built by human engineering. What you see above the water is only a small part of the entire structure. The real engineering masterpiece lies far below the surface, hidden beneath hundreds of meters of seawater. Supporting the platform is a gigantic steel framework known as the jacket. These massive steel legs extend deep through the ocean until they finally reach the seabed. But simply touching the seabed isn't enough. If the platform only rested on the ocean floor, powerful waves, ocean currents, and decades of constant movement would eventually cause it to shift. Engineers needed something much stronger, so they created a foundation that works much like the roots of a giant tree. After the jacket is positioned on the seabed, enormous steel piles are driven through the legs of the structure and hammered deep into the ocean floor. These aren't ordinary piles. Some are more than 2 meters in diameter. Some are driven over 100 meters beneath the seabed. Together, they lock the entire platform firmly into the earth beneath the ocean. It's this hidden foundation that carries the enormous weight of the platform. The drilling equipment, the cranes, the production facilities, the living quarters, and even fully loaded helicopters landing on the heli deck. But weight isn't the biggest challenge. The ocean never stops moving. Every wave pushes against the structure. Every current applies enormous force. Every storm tries to bend the steel. Instead of resisting every movement, engineers designed the platform to work with the ocean. The jacket is incredibly strong, yet flexible enough to absorb energy from waves without suffering damage. That slight movement is completely normal. In fact, If the platform were perfectly rigid, it would actually experience greater stress during storms. Allowing the structure to flex slightly helps distribute enormous forces safely throughout the framework. Long before construction ever begins, engineers use advanced computer simulations to predict exactly how the platform will behave. They calculate wave heights, ocean currents, wind speeds, seabed conditions, and even the possibility of earthquakes. Every beam, every brace, every welded connection is carefully designed to withstand decades of punishment from one of the harshest environments on Earth. And that's why, when enormous waves crash into an offshore platform, you're not watching a structure fighting against the ocean, you're watching one that was engineered to work with it. Being firmly anchored to the seabed is only part of the story. The real test begins when the weather turns against the platform. Out in the open ocean, storms can arrive with incredible force. Towering waves crash into the steel structure. Powerful winds push against cranes, living quarters, and drilling equipment. Ocean currents pull from different directions at the same time. To most people, it looks impossible. How can thousands of tons of steel survive such punishment without breaking apart? The answer lies in the way offshore platforms are designed. Unlike a concrete building on land, an offshore platform isn't meant to remain perfectly still. It is designed to move, only slightly, but enough to absorb the enormous energy carried by the sea. As giant waves strike the platform, the structure flexes gently. Steel braces distribute the force throughout the entire framework. Instead of allowing one section to carry all the stress, the load is shared across hundreds of interconnected beams. This greatly reduces the chance of structural damage. But engineers don't stop there. Long before construction begins, every offshore platform is tested using advanced computer simulations. Engineers recreate some of the worst weather conditions nature can produce. Hurricane-force winds, towering waves, powerful ocean currents, even earthquakes in regions where seismic activity is possible. If a design cannot survive these virtual tests, it is redesigned before a single piece of steel is ever built. The platforms themselves are also built using extremely high-strength steel, designed to withstand decades of harsh offshore conditions. Protective coatings help prevent corrosion caused by salt water. Special cathodic protection systems reduce rust beneath the waterline. Every weld, every joint, every support is inspected repeatedly during construction, even after the platform begins producing oil and gas. The engineering never stops. Sensors continuously monitor parts of the structure. Engineers carry out regular inspections. Remotely operated vehicles known as ROVs inspect underwater components that divers cannot easily reach. If even the smallest crack or sign of corrosion is discovered, repairs are planned long before the problem becomes serious. This constant attention is one of the reasons many offshore platforms continue operating safely for decades. So the next time you see enormous waves crashing against an offshore platform, remember, the platform isn't surviving because it's lucky. It's surviving because thousands of engineers carefully planned for that exact moment, years before the first storm ever arrived. By now, you know why offshore platforms don't sink. You know about the giant jacket structure, the massive steel piles buried deep beneath the seabed, and the incredible engineering that allows these giants to survive some of the harshest conditions on Earth. But here's something many people never realize. Building an offshore platform is only the beginning. Keeping it standing safely for decades is an even greater challenge. Every single day, offshore engineers inspect the platform for signs of wear. Salt water never stops attacking the steel. Powerful waves constantly place stress on the structure. Wind, rain, heat, and changing ocean conditions slowly take their toll. That's why inspections never stop. Highly trained engineers examine critical equipment. Maintenance crews replace worn components before they fail. Special protective coatings are renewed to fight corrosion. And, beneath the ocean, remotely operated vehicles, known as ROVs, carefully inspect underwater sections of the platform that divers cannot safely reach. Every bolt, every weld, Every support beam is treated as a critical part of the structure, because offshore, ignoring a small problem today could create a much larger one years later. But perhaps the greatest strength of an offshore platform isn't the steel, it isn't the concrete, and it isn't the technology. It's the people. The engineers who spend years designing these incredible structures. The inspectors who notice tiny defects long before they become dangerous. The maintenance teams who work through challenging conditions to keep every system operating safely. And the offshore crews who follow strict procedures every single day. Together, they make it possible for platforms to continue operating safely, year after year, decade after decade. The next time you see an offshore platform standing alone in the middle of the ocean, remember, you're not just looking at thousands of tons of steel, you're looking at decades of engineering, millions of hours of maintenance, countless inspections, and the dedication of people who refuse to compromise on safety. That's the real reason offshore platforms don't sink. Not because they're indestructible, but because every single day people work tirelessly to make sure they never stop standing. And that is one of the greatest engineering achievements in the modern world.
So today we've learned that offshore platforms don't stay standing because they're lucky. They stay standing because they're engineered that way. And behind every platform are engineers, inspectors, and offshore crews working every single day to keep everyone safe. I'm Hillary. Thanks for watching. If you enjoyed this documentary, subscribe and share it. Share it with someone who's curious about how offshore platforms really work. What do you think about offshore platforms? Share your thoughts in the comments. I read every one of them, and I'll see you in the next video.